back. Now we'll look at time series graph. A time series graph is a graph showing data measurements in chronological order. Chronological means in order of time. To make a time series graph, we put time in the horizontal scale and the variable being measured on the vertical scale. In a basic time series graph, we connect the data points by line segments. That is, in a time series graph, data are plotted in order of occurrence at regular intervals over a period of time. So let's look at an example. So, suppose you have been in a walking, jogging exercise program for 20 weeks. And for each week, you have recorded the distance you covered in 30 minutes. Week 1, 1.5 miles. Week 2, 1.4 miles. Week 3, 1.7 miles, and so on. You have built such a data, right? Now, you want to make a time series graph. The data are appropriate for time series graph because they represent the same measurement, that is distance covered in a 30-minute period taken at different times. Measurements are also recorded at equal time intervals, that is every week. To make our time series graph, we list the weeks in order on the horizontal scale, and above each week, plot the distance covered that week. For example, here, so these are the weeks: week 1, week 2, week 3, so on until week 20. So notice how you have a squiggle there. So that is like pushing the scale, because 1 to 2 is so big, right? 0 to 1 has been pushed down. That's all. So you start at 1.5, 1.4 second week, 1.7 third week, and so on. So this is a time series graph. You can see how much exercise you are able to get in 30-minute periods, right? So now, can you detect any patterns? Well, look at that. Can you detect any patterns? There seems to be an upward trend in the distance covered. Distances covered in the last few weeks are about a mile farther than those in the first 2 weeks. However, we cannot conclude that this trend will continue. Perhaps you have reached your goal for this training activity and now wish to maintain. So distance, how much you are able to exercise or cover has been steadily increasing, but we are human after all. In 30 minutes, you cannot keep increasing the distance. At some point, it will remain stable. Okay, so that's all. Say maybe 2.5 miles in 30 minutes. That's all we want to keep at. Data sets composed of similar measurements taken at regular intervals over time are called time series. That was an example of time series. So similar measurements taken over regular intervals of time. Time series are often used in economics, finance, sociology, medicine, and any other situation in which we want to study or monitor a similar measure over a period of time. Time series graph can reveal some of the main features of a time series. Time series data consist of measurements of the same variable for the same subject taken at regular intervals of over a period of time. Okay, how to decide which type of graph is a graph to use? Bar graphs, used for quantitative or qualitative. With qualitative data, frequency or percentage of occurrence can be displayed. With quantitative data, the measurement itself can be displayed. Okay, watch that the measurement scale is consistent, that a jump scale squiggle is used if you are going to change scale. Pareto charts identify frequency of events or categories in decreasing order of frequency. So Pareto charts are essentially bar graphs, except you uh, the the tallest bar is drawn first, and then you proceed. Okay. Now this is Pareto charts is done for events or categories. Okay. So circle graphs display how a total is dispersed into several categories. Circle graph is very appropriate for qualitative data or any data for which percentage of occurrence makes sense. Circle graphs are most effective when the number of categories or wedges is 10 or fewer. Time series graphs display how data change over time. It is best if the units of time are consistent in a given graph. For instance, measurements taken every day should not be mixed on the same graph with data taken every week. So you must be consistent. If you are going every day, then you make a time series for every day. If you are working with every week, then make a separate time series for every week. Now, for any graph, provide a title, label the axes, identify units of measure. The visual display of quantitative information. This is a book written by Edward Tufte. Don't let artwork or skewed perspective cloud the clarity of the information displayed. So it's very important to display your information correctly. All right. Okay, so this completes section 2.2 lecture. I will continue in the next video with section 2.3. Until then, bye.